Alright, this is John Black, Super Chemist, showing you the chemistry of chromium metal. Before I do that, I want to start off with telling you what ligands are and dative bonds. As you can see up here, you got two kinds of bonds here, right? This one, they both have the same electronegativity, therefore the bond is evenly distributive. You have a covalent bond. This one right here, though, chlorine is a lot more electronegative. This is electropositive. So that makes it an ionic bond. So the chlorine hogs these electrons that they're sharing, but they're still sharing. See, red, red, blue, blue. Each one donates an electron to the bond. What would happen if only one of the atoms donated the electrons? Then that would be considered a dative bond, okay? And that forms what's known as a coordination complex. Whatever donates the electrons is considered the ligand. Now, in this case with chromium, this is just a fictitious ion. It's the simplest coordination complex here, but I don't think it really exists. But just to give you an example, basically what the deal is chromium is a transition metal. As such, it has d orbitals. These d orbitals, even though they're not filled, are still there and can be filled. Let's say chromium's there and it has all these empty d orbitals, and here's water, oxygen, with the two lone pairs sticking out there. One of these lone pairs can fill one of the d orbitals of the chromium. As you can see, it happens 6 times here. The chromium itself is a +3. The water ligands are neutral because they are donating both electrons. They're just neutral. So overall, this has a +3 charge. All right, now the first video, we started out putting chromium metal into hydrochloric acid to make chromium chloride, chromium 3 chloride, and hydrogen. Metal plus acid, salt, and hydrogen. And that's the way they say it in general chemistry. And you would think of this as a chromium on one side being +3 and 3 chlorides on the right. They're the -3 if you put it into water. But that isn't actually the case, okay? This is the actual case. Chromium, remember up here, the +3, if it had the waters all around it, what would happen is this water and this water were substituted by chlorides, 2 chlorides. Now, if it was a +3 and these 2 chlorides are negative, that's 2 negatives and 3 positives. 3 minus 2 is 1. So this is a 1, and then your third chloride would be over here floating around as an ion in solution. So this is actually the way it looks. And then you have 4 water ligands forming a coordination complex. And these are the reds with the water. Those are dative bonds. Now, I isolated this, I think, a little bit of it, but you don't really have to. You can just go from there. Step is to put this into water. So if you crystallize it out, well, you're just going to have to throw the crystals back into water. So why even get the water out in the first place? Now, if you remember in the next video, we took our chromium chloride. We added 3 moles or 3 equivalents of sodium hydroxide. And in general chemistry, they tell you get 3 sodium chlorides and chromium 3 trihydroxide, okay? And that's how you would write it. But that isn't the way it is. If you look down here, what happens is, see how you got your 2 chlorines, right? Well, this sodium hydroxide mixes with that, makes sodium chloride, and replaces them with OHs. See how I replaced it? Now the third sodium hydroxide, there's no more chlorines, right? So it comes along, this is a base, it deprotonates one of these water ligands and makes a OH out of it. Now that H ends up coming over with this negative ion, right? Because this is +H, negative, you get hydrogen chloride. Instead of 3 sodium chlorides, you actually only get 2 sodium chlorides, and you get 1 HCl. Now, I normally add in another equivalent or another mole of sodium hydroxide, and it neutralizes this so that you would have 3 moles of sodium chloride. So in essence, this is true. If you don't add the extra mole of the sodium hydroxide, think about it. You're making HCl, right? So when you get done adding your 3 moles, you'll have a mole of HCl there. Now that HCl, it's going to react with the sodium hydroxide that was in there. So all 3 moles aren't going to have a chance to react because they're going to react with the hydrogen chloride that's made and make sodium chloride and water, right? So if you put an extra mole in, it will neutralize that HCl, and then the other 3 moles can do their work on the chromium coordination complex. As you can see, this is the same formula as this. You got 1 CR, 1 CR, 3 hydroxides, 3 hydroxides. The water molecules are neutral. They're ligands forming dative bonds. And this whole thing is neutral because the chromium is +3. These are -3. They're ligands too, but they're have an extra electron to be ligands. And this is what was insoluble. Then remember, we wished it out several times with water to get all this sodium chloride out. This is soluble, this isn't. So we threw some water in, soaked up the NaCl, threw the water out, put some more clean water in, soaked up some more NaCl, and it kept repeating that until we got nice, clean chromium hydroxide. So this is actually called chromium triaqua trihydroxide coordination complex. What happens here is this insoluble chromium hydroxide, it has these ligands, as we know, right? And that makes it acidic, because we know water can be acidic or it can be basic. But when you put it in with this sodium hydroxide, this is really basic. So what will happen is, just like an acid and a base, what are you going to make? Salt water. Here's your salt, and then I didn't write it down, but it also makes water, obviously, 3 waters. So here's what that salt looks like. You can see it's like a khaki green. There's a little bit of chromate in there, but 99% of it is that green coordination complex. Now this is what I got extra from a couple experiments. Each good experiment, I got at least 2 grams of this back, so that means it didn't react to, go on to the next, to go on to make chromate. So if I added 44 grams in, really only 42 reacted. 2 of it made this, but it didn't continue on to the chromate. And as much as they say this is soluble in alkaline solution, I've had this up to like 10, a ratio of 10 moles, 10 to 1, and I still can't get it to dissolve all of it. I always end up with at least a little bit left over that didn't dissolve. Okay, I just want you to see the difference in comparison. The one on the left has just chromium hydroxide and water. I only let it sit for a while because it's a little cloudy, but if you let it sit over a day, it'll definitely be clear as can be. But if you look at the 2 on the right, they have chromium hydroxide and water, but they also have hydroxide in with them. And you can see the top layer there where it's just water. All the precip is at the bottom there. But at the top where it's liquid, just liquid, you can see it's green. And that is the sodium, chromium, hexahydroxide coordination complex salt. That's the green, brown, khaki green. And no matter how long you wait, it'll stay green because it's soluble. So the stuff on the right, the far right, has a 10 to 1 ratio. Meaning if I have a mole of chromium hydroxide in there, I put 10 moles of potassium or sodium hydroxide. So it's alkaline. No matter what I do, I cannot get it to dissolve. I can add another gallon of water to that. I could heat it up forever, stir it, whatever. Only so much seems to dissolve no matter what I do. Now the middle one has a 4 to 1 ratio. And you can see it has the same amount of precip. I mean, and these have been sitting for like a day. Now the one on the left, it hasn't been sitting that long because I know it'll just clear up more and more. Because all it is chromium hydroxide, no sodium hydroxide. So nothing soluble. But no matter what I do, I cannot get that to dissolve completely. This deprotonates that, right? And look how all these H2Os turn into OHs now. See there? And it also, each time it does that, if it takes a proton off each time, and each time it used to be neutral, now it's -1, -2, -3. And I have that right there. And it does it 3 times, and that's why you get 3 sodiums. So that'd be +3, -3. So anyone can buy chromium metal online. Nobody cares. It's just metal. I mean, it's metal. I showed the video how to make the chromium 3 chloride, how to make chromium hydroxide from that, and all the chemicals you needed. I showed where to get them at Lowe's or at Walmart or the grocery store. And now my last video, I showed how to make potassium dichromate with the chromium hydroxide. And that's where the next video comes into. I'm going to use the stoichiometry. If you noticed, I haven't used any stoichiometry, like, oh, I used 10 grams of this and 20 grams of that. The next video, I will start doing that. And I'm taking the stoichiometry from my last video, which was how to take chromium hydroxide, which is where we left off here, and make it into potassium dichromate. So this next video coming up is not only part 2 of this video, it's part 2 of last video too. And always remember, science is great.